News of the World. Today in News of the World, the future is here. We travel to a scientific laboratory to show you the latest advances in measurement and the wonders of modern science. pH is a measurement of hydronium ions, or whether something is an acid, a base, or neutral. It's gotta be right, or you'll denature your protein, inactivate your enzymes, or maybe even kill somebody. Scientists have cracked the case with the Acumet XL25, a space-age device that gives spot-on numbers at the touch of a button, measuring the difference between the electrical potential inside and outside of the probe, which creates an electromotive force linear to the pH. The glass electrode is filled with potassium chloride to initiate an ion exchange with the hydronium ions in the solution. The technician rinses the probe with distilled water and dips the probe into the solution. The arm keeps the probe still to prevent disruptive currents. The computer box shows the readout as it happens, and the technician must wait for the reading to be confirmed. The probe is rinsed and stored in a special protective cover that keeps it moist so the readings don't go haywire. When operated by trained workers, this miracle device will give accurate readings every time, provided it's calibrated before each use with standard low, neutral, and alkaline solutions. Over at the spec bench, this scientist is operating a Genesis 10S ultraviolet spectrophotometer. This machine measures the amount of light absorbed by the sample, which the scientist can compare to the standard curve to find the concentration. The machine can also be programmed with a standard to provide a concentration reading right off the bat. The 1 milliliter sample is loaded into a special optical cuvette, which is wiped free of fingerprints that could interfere with the reading, then placed on the carousel. Another cuvette is loaded with a pure version of the sample to provide a baseline. The scientist measures the blank, or pure sample, first to get straight zeros on the readout, then presses the 1 key to move the sample in front of the light to find out the concentration normalized to the pure solution. The NanoDrop ND1000 works just like the Genesis, but it only needs 1 or 2 microliters of the sample. The secret is a special pedestal, where the drop is placed directly onto the tiny window. When the pedestal arm is lowered, surface tension forms a 10mm bridge for the light beam to travel through. The NanoDrop is operated through an electronic computer, which allows the machine to apply the right calculations to an accurate measurement. This lab works with nucleic acids and proteins. The nucleic acid option measures DNA, RNA, or single-stranded DNA, and the protein option lets the scientist choose the type of protein measurement they want to use. Choosing the right one is important because it tells the computer what conversion factor to use to calculate the concentration. The pedestal is cleaned and blanked, and the sample is loaded. The machine provides a readout of absorbance along the full spectrum, but the most important part is the peak. Nucleic acids absorb highest at 260 nanometers, so the machine multiplies that measurement by the right conversion factor and the dilution of the sample to give the concentration in nanograms per microliter. Proteins absorb best at 280 nanometers, so the machine plugs that measurement into the Beer-Lambert law to give the concentration in milligrams per milliliter. Both sample types are isolated from cells, so the ratio of absorbance at 260 and 280 tells the scientist if the nucleic acid is contaminated with protein or vice versa. It's a great time to be alive as scientific progress leaps forward and pushes us to victory. With the world's biggest minds working on our side, the future's looking bright.